The Earth's core is hiding a glittering secret.
But now scientists say the Earth's core is leaking.
Researchers just discovered something in Hawaiian volcanic rocks that could change everything we thought we knew about what's happening beneath our feet. An isotope that shouldn't exist at the surface. A chemical signature that doesn't match any meteorite, any mantle rock, or any known surface material, leaving only one impossible explanation. It came from Earth's core, bleeding upward from 1,800 miles down, where 99.999% of the planet's gold is locked in molten iron at 5,000 degrees Celsius. The core wasn't supposed to leak. The boundary separating it from the mantle above was thought to be sealed, impermeable, keeping Earth's heart isolated from everything else. But the isotopes prove otherwise, and what they reveal about how fast the core is losing heat, and what happens when the dynamo powering Earth's magnetic field cools past a critical threshold, is something governments have been quietly monitoring, but not publicly discussing. If you care about what's happening 3,000 kilometers beneath your feet, and why the process keeping Earth alive might be running faster than anyone predicted, share this everywhere. Because what scientists found in Hawaiian lava doesn't just prove the core is leaking, it proves the boundary between the core and mantle isn't sealed. And if material can flow out of the core, that means heat is escaping faster than models assumed. Which raises a question nobody wants to answer. How much time does Earth's magnetic field have left? Before we break down exactly what ruthenium isotopes reveal about core-mantle dynamics, why hundreds of quadrillion metric tons of superheated rock are rising from the core-mantle boundary, and what happens when Earth's dynamo shuts down and the magnetic field collapses, leaving the planet exposed to solar radiation that will strip away the atmosphere the same way it did on Mars. Subscribe to this channel for the deep dives nobody else will give you. First, you need to understand why gold ended up in Earth's core. Because the answer involves the violent birth of the planet itself. When Earth formed 4.5 billion years ago, it was essentially a giant ball of molten rock. As the protoplanet melted and separated into layers, dense metals like gold, platinum, and ruthenium sank through the viscous primordial rock, pooling in the nascent core. This process was remarkably efficient. More than 99% of Earth's gold ended up locked in the core. All the gold humanity has ever mined, about 216,000 tons, would fit in a cube just 73 feet on each side. Every piece of jewelry, every gold bar in Fort Knox, every electronic component using gold in your smartphone. Meanwhile, Earth's core contains an estimated 30 billion tons of gold, enough to coat every bit of land on the planet in a layer almost half a meter thick. So how is any gold at the surface? The traditional explanation involves meteorites. After the core formed, a cascade of space debris delivered a small replenishment to the crust and mantle during what's called late accretion. These meteorites carried a slightly different isotopic signature of ruthenium, and that's the fingerprint scientists use to trace where elements came from. But the Hawaiian rocks told a different story. Dr. Nils Messling's team analyzed basalt samples from volcanic islands and found elevated levels of ruthenium-100 enriched in S-process nuclides, a signature that originates in stellar environments and was locked into Earth's core during its early formation. One isotope, 10Ru, is slightly more abundant in core materials than in the mantle. The difference is subtle. But with new purification techniques and painstaking mass spectrometry, researchers detected a consistent elevation of 10Ru in Hawaiian lavas. That shouldn't happen, unless something from the core is mixing into the molten rock rising from deep within Earth. The Earth's core is not as isolated as we thought, said Professor Matthias Wilbold, who co-authored the study. Huge volumes of superheated mantle material, several hundreds of quadrillion metric tons of rock, originate at the core mantle boundary and rise to Earth's surface to form ocean islands like Hawaii. These rising jets of molten rock are called mantle plumes. In 2015, researchers using sophisticated earthquake wave analysis found evidence for 28 mantle plumes, most beneath volcanic hotspots, rising continuously and vertically from the core. The plumes are 600 to 800 kilometers wide, more than 3 times as big as models predicted. And now we know they're carrying core material with them. The amount of core material in any single volcanic rock is minuscule, less than 0.3% according to the research. The researchers propose that adding less than 0.25% of core material to mantle rock can explain the observed isotope patterns. But multiply that by millions of years of volcanic activity across all the hotspots on Earth, and suddenly, the precious metals at the surface start to make sense. The team considered several mechanisms. One scenario involves the formation of an oxygen-rich layer in the outer core that crystallizes over time, allowing selective leakage of metals like ruthenium and tungsten. Another hypothesis suggests that as Earth's core slowly cools over geological time, it may crystallize thin layers of metal oxides that are enriched in certain elements. Here's where the discovery becomes terrifying, and it has nothing to do with mining gold. Earth's core is cooling. That's not news. All planetary cores cool over time. But what the ruthenium leak reveals is that the core mantle boundary is far more permeable than models assumed, which means heat is escaping more efficiently than scientists predicted. And the core's heat is what powers Earth's magnetic field. In the extremely hot temperatures deep in Earth, the core is a mass of swirling, molten iron which acts as a dynamo. As the molten iron moves, it generates Earth's global magnetic field. Convective currents keep the dynamo turning as heat flows out of the core and into the mantle. The magnetic field extends far into space, forming the magnetosphere, which deflects charged particles from the sun and cosmic radiation. Without it, solar wind could strip away Earth's atmosphere over time, affecting the planet's habitability. We have a real-world example of what happens when a planet loses its magnetic field: Mars. Mars once had a magnetic field. Then its core cooled below the critical threshold, the dynamo shut down, and the planet is now constantly bombarded by charged particles that make life difficult. Its atmosphere was stripped away. The surface became sterile. Research from 2022 warned that Earth's core may be cooling more rapidly than expected, which could speed up the timeline for when the planet becomes uninhabitable. When the planet gets cold enough, it will begin losing its magnetic field, which protects Earth from damaging cosmic radiation. This would ultimately lead the planet to become sterile and unlivable. But there's a complication that makes the timeline harder to predict. Earth's inner core, a solid sphere of iron and nickel about 1,200 kilometers in radius, didn't always exist. The inner core crystallized around 1 billion years ago. Before that, the core was completely liquid. For decades, geophysicists debated whether the magnetic field could have existed before the inner core formed, because the crystallization process releases heat that helps drive convection. A 2025 study published in Nature by researchers from ETH Zurich and SUS Tech, China, finally resolved the question. They demonstrated that Earth's liquid core could generate a stable magnetic field even before the inner core crystallized, because core viscosity has negligible influence on the dynamo effect. But here's the critical point. As the inner core slowly solidifies from the liquid outer core, it releases latent heat of crystallization and expels lighter elements into the outer core. Both processes help maintain convection in the liquid iron surrounding the inner core. The inner core grows several tens of millimeters per year, that is, 500 kilometers per billion years. When in a few billion years the inner core occupies most of the core, Earth's magnetic field will be extinguished. And there's already evidence the field is weakening in specific regions. Research by Dr. Jonathan Mound and Professor Christopher Davies from the University of Leeds found that core cooling does not happen uniformly across Earth. Seismic analysis identified regions of the mantle, under Africa and the Pacific, that are particularly hot. These hot zones reduce the cooling effect on the core, causing regional changes to the magnetic field. Where the mantle is hotter, the magnetic field at the top of the core is weaker. This creates a weaker magnetic field projected into space above the South Atlantic, causing problems for orbiting satellites. When the magnetic field is weaker, this protective shield is not so effective, Dr. Mound explained. When satellites pass over that area, these charged particles can disrupt and interfere with their operations. The implications go far beyond satellite interference. Without the protection of the magnetic field, solar wind could strip away Earth's atmosphere over time, affecting the planet's habitability. Changes in geomagnetic activity may affect wildlife behavior, including the navigation of migratory birds, sea turtles, and marine mammals. It could impact global weather patterns, including shifts in precipitation, temperature, and storm intensity. And disruptions to satellite communications, power grids, and GPS navigation systems would occur in the absence of a robust magnetic shield. So what's the timeline? Andrew Rushby of the University of East Anglia forecasted in 2013 that Earth could remain habitable for between 1.75 billion and 3.25 billion more years, assuming no nuclear holocaust, rogue asteroid, or other catastrophe. But that estimate assumed a specific cooling rate. The ruthenium leak suggests the cooling might be faster, because if the core mantle boundary is permeable enough to let heavy metals bleed through, it's permeable enough to let heat escape more efficiently than models predicted. The deepest humans have ever drilled is the Kola super deep borehole in Russia, which reached 12,262 meters, about 0.2% of the distance to the core. We can't access the core. We can't slow its cooling. We can only watch as mantle plumes continue carrying tiny traces of gold and ruthenium upward, evidence that Earth's heart is bleeding, one isotope at a time. One thing is absolutely certain. Scientists found ruthenium-100 in Hawaiian lava with an isotopic signature that could only come from Earth's core. The discovery proves material is leaking from the core into the mantle through mantle plumes carrying hundreds of quadrillion tons of rock. 99.999% of Earth's gold remains locked 1,800 miles down, but the leak reveals the core mantle boundary is permeable. The core powers Earth's magnetic field by cooling, and when it cools enough, the field will collapse, exposing Earth to solar radiation that stripped Mars's atmosphere. Researchers warned in 2022 the core may be cooling faster than expected. We found gold leaking from Earth's core. What that means is we're watching the planet's heart slowly die, and there's nothing we can do to stop it.